chapter is that? All right. How are we doing, Logan?
All right.
Good. Glad you could join us. We're just about ready here. I have to go get my book, though. I think I left my book in my office. Ugh. All right. Let's. There we go. You are screen sharing. Congratulations to me. And I'm recording. Okay. Oh, I should check to see something here. Physics engineering. Chapter 8 was the last one I uploaded. I need to check to see where chapter 9 is here. So today is the 24th. Last Wednesday would have been the 17th. The one before that would have been the 10th. So we do have a video from there. I have to upload a bit of the video really quick, sorry. 10th. 10. Chapter 9. MATLAB. There you go. All right. All right, so that's good. Let's move on to our next chapter, which is not chapter 10. In chapter 10, we do a bunch of matrix mathematics, which is a little beyond this class. I don't think there's anything here really that we need to yeah. Nothing really that we need to know from chapter 10 for our level of MATLAB and mathematics. One thing that you should be aware of, though, is that when you do take a class in vector calculus or matrix algebra or linear algebra or multidimensional calculus, that is where MATLAB really starts to excel. MATLAB is really good at doing math in multiple dimensions because of its ability to do math with matrices. Suffice it to say that you can represent multidimensional math. When I mean multidimensional, I mean you've got a bunch of equations that are x, y, z, and t dependent, for example. So x, y, and z being the 3 dimensions of space and t being time. So you can use these equations to describe motion in 3 dimensions. You can use them to describe forces and dynamics in 3 dimensions. But the problem is that each dimension has to be solved independently, and that's very difficult to do when they're intermixed, when they're interdependent. So so MATLAB can do that. You can represent them as matrices, and then you can have MATLAB do the work for you, essentially. So when you do get to that point, realize that MATLAB has this capability, and then you can learn about that there. You probably will learn it in whatever class you're taking that involves those kinds of things. Maybe not in like Calc 3. If you're in Calc 3, they probably won't. I don't think anybody here, and I know that nobody in North Platte can program that teaches Calculus 3. I know that none of our math department knows anything about programming. If you're taking Calculus 3 from Michael Jonquier and McCook doing distance learning, he definitely knows programming. I don't know how much MATLAB he knows, but he knows Mathematica really well, which is a similar program, not quite designed the same way as MATLAB for matrices, but it still can handle them. Not quite as well, but still does. Anyway, I know that he has experience with that, but I don't know if he uses it in his class. I've never asked, but certainly if you go further into engineering, you will definitely be using computers to do stuff like this. We're going to skip to chapter 11, however, so now we're on page, whatever this is, 398, chapter 11. Now, chapter 11, we're going to do, we're going to be creating and introducing you to other things that you can put into arrays or matrices. They don't call them matrices when they're not numbers anymore, or they're mixtures of things. They call them arrays, but we often use the names back and forth anyway. We often say an array is a matrix is an array. It's just, they're almost synonymous. In MATLAB, they make them a little bit different, but doesn't really matter. So that's what we're doing with this one. We will actually do some work with some of these arrays, some actual problem solving and things like that, as well as we go through this. I'm trying to remember all the stuff that we do. Eventually, yeah, I mean, we do some actual programs. We don't just introduce you to them and then don't do anything with them. We do some things with these, not as much as in previous chapters, which is kind of nice, but that's all right. This stuff can get a little bit confusing, so if you have any questions, feel free to raise your hand and ask questions. Don't hesitate to interrupt and stop things, but let's go ahead and get started. Other kinds of arrays, starting on page 398. So the first thing that we have to kind of realize is that MATLAB, whenever you enter something into MATLAB, it either assigns it some kind of type, or it either assumes a certain type from what you've typed in, or you can assign it a particular type. And what do I mean by type? Well, MATLAB is expecting you to assign names to data. So the name is the thing that you assign it to. Like if we're starting here on page 399, A, that's the name. A is the name, and I put this equal sign, which means assign. It means make A equal to, and then you're going to assign it to something. In this particular case, we assign it to 1. And if we go over here and we look in our workspace and you click on this, if you double click on it, for example, to open it up, or just hover on it or whatever, it brings you up this thing and it tells you it's a 1x1 double. 1x1 tells you the size of the array or the size of the matrix, and the double tells you the type of data this is. So this is a double. I think it's double precision. This would be called a double precision floating point number. Now on page 399, they actually give you a bunch of the kinds of data that can be stored in MATLAB. In matrices, you can store, if you look on this in this chart down here at the bottom of the page, and I can point my camera at it so that you can see it here really quick. Share my camera with everybody. That's not helpful. New share. No, I'll just stop sharing. Okay, so we're looking on page, this is page 399. And if you look down here on the right side, which now looks like your left side because it's all backwards, it's not focusing on this for some reason. Too much light, too little light, I don't know. It has these floating points, and my hand is shaking a little bit there, so it didn't help. There we go, floating point. And we have the double precision number right there, and that's backwards, and I could switch it around, but it'll take too much time. So that's what that means. That double means it's a double precision floating point number. But there are others you can also have. You can see over here that you can have integers, and that's backwards again. You can also have characters. You can have logicals. You can have a logical matrix. You can have a numeric matrix, categorical matrix, a time matrix, and symbolic matrices. So all these are different types of matrices you can have. And it depends on what you're saving and how you save it, essentially. Now on the next page, we have MATLAB array types. You can have different types of arrays. Well, what's the difference? And what kinds of arrays can you have? Well, here you can see there's single data type arrays that can be categorical, character, logical, numeric, time, symbolic. And you also have this, you can have sparse arrays over here. And then you can have multiple data type arrays that are formed in the form of tables, cell arrays, structure arrays, and maps. Now, the point of all this is not for you to understand each one of these and to remember each one of them necessarily. The point is to show you that MATLAB is extremely capable of doing a lot of different things. So why would we do these? Why would we use these different kinds of arrays? Well, for different kinds of data, you maybe want to store it differently, treat it differently, and have MATLAB understand that. Now, you remember back when we were doing charts, when we were having you make a chart of the angles in radians and angles in degrees, for example. You had a hard time kind of putting together that chart, and kind of had to figure out a way to just print it to the screen so it looked like a chart. Well, you can actually make MATLAB understand that it's a chart by entering it in a particular way. And you can make MATLAB understand that the first column is just is all radians and the second column is all degrees. And you can actually make MATLAB give each of those columns a title. And you can make MATLAB give them different colors. And MATLAB can understand, can label these things, and it can categorize them. It can remember what these things are, so that you don't have to try to figure out just how to print it to the screen. It's a little more involved than just printing things to a screen, which is why we don't teach you that in chapter 3 or 4 or something like this. But it can do it. And that can be very useful if you don't want your data just coming out as, just a big string of numbers, a big line of numbers. If you want your data to come out so that it's understandable by anybody who's looking at it, MATLAB knows how to do that. And it's great for that, because then you can use MATLAB to not only write a program for calculating things, but you can make MATLAB a great program for inputting data in. Even if you don't know MATLAB, you can write the program so that somebody who doesn't know MATLAB can input the data. We've already learned how to, prompt the user to input stuff. But you can also write MATLAB to look at a file, to look like at a Word file, and to extract a table of data from it, because it knows those things are numbers, and it can recognize them and can put them into a table. And it can also look at that same table and look at the titles at the top of the table and put those in the proper place in MATLAB. MATLAB can distinguish the difference between these things. So it makes it an extremely powerful tool for doing real work in the real world, which is what it was designed for. Exactly that. So that's why we're trying to help you to understand the different kinds of things that MATLAB can recognize, the different ways that MATLAB can organize things, the different ways that MATLAB can work with these things, do calculations, do whatever it needs to do with these things. And we're going to get a fair amount of that in this chapter. And that's really why this chapter is different, because we're looking at more of the capabilities of MATLAB rather than doing more programming with MATLAB. We're just kind of expanding your knowledge of what it can do. So, going back now to our MATLAB. So this right here is an array that is 1 by 1. So it has one row and one column. It's actually still considered a two-dimensional array because it has row and column, right? Even though it only has one row and one column, it's still considered two-dimensional because it can be expanded. For example, if we open this up, we can actually add more things to it because it is two-dimensional. It has rows and columns, even though it only has one value in it. And of course, if you make another, you can do this whole colon thing, right? And make another two-dimensional array. And this one is obviously two-dimensional, maybe not obviously, but it is still two-dimensional. It has one row and 10 columns. And of course, you could add more rows to it just by typing it in here. And then one that's definitely obvious is the one that looks like this, where you say C equals, and you put in your square brackets, and you put in some values, whatever they are, and then you get a new row going, sorry, and you put in some more values. That's too many. One, two, three, four. 1, 2, 3, 4. Oh, sorry. 2, 3. Oh, it was right. I was right before. I had 5 in the first one, and I need 5 in the second one. There we go. Now we're good. So this is definitely two-dimensional. Has 2 rows, 5 columns, and that definitely makes sense that it's two-dimensional, even though all of them are two-dimensional. That one just is the most obvious one that is two-dimensional. Of course, these are all numeric arrays, double precision, floating point. And if you want to change the type of numeric array that you're typing in, you can do it a couple of different ways. You can actually choose to create a particular type of array by changing the type of the values that you're putting in, and that requires actually doing a little bit of code, changing the type of the numbers that you're putting in. You could change it so it's all integers, so that these numbers are not saved as 1.0000 or whatever. It's saved as just 1, and it can't be saved as anything else. And you can also save them as other types of numbers. Plenty of types of numbers available to you. Um, these are, I think that these, I don't think we've talked about these before, but this function, real max in MATLAB, tells you the largest possible number that you can express using double point precision. If you're using single point precision at the time, it will tell you the biggest number that you can use for single point precision. Those are different. So that's the biggest number that you can possibly enter into MATLAB, or you can calculate in MATLAB. If you calculate something bigger than that, it will show you the INF, the infinity number, which you've probably all seen as you've made different mistakes in your calculations, or even done it on purpose. But then you can also do the real min, which tells you the smallest number that you can create in using that particular type of number, the double precision in this case. So, and here you can actually see this. So if the real max is 1.7 times 10 to the 308, and we try to enter in x equals, 5e to the 500, right? Try to enter that in, and it just says x is equal to infinity. It just can't deal with that. And you can do the same thing the other direction to go smaller. You can say if x equals 9e to the minus 400, it just calls it 0. It just doesn't, it can't deal with numbers that small. So what if we wanted to go to single precision floating point numbers? Well, top of page 401, we do this. D is going to equal now. We're going to force it by using a command, single, 5. So D is going to equal a single, now if we go over here and hover up above this, maybe. It's a 1-by-1 single now. Single precision floating point number. And if we want to know what the biggest number we can do here in the single, we have to actually say that we want to know it for single. So we type in single here. There is a way to turn on single floating point precision for all that you're doing in MATLAB, but we're not going to mess with that right now. But if you want to know what the biggest maximum number you can make in the real numbers for single precision floating point number. There we go. Single precision floating point number. Then you type in real max quotes single, and it'll tell you that it's 3.4 times 10 to the 38. Before it was what, 1.7 times 10 to the 308. This only goes to the 38. So this one is way bigger, gives you much bigger numbers than this one does. And then you can do the same thing with the real minimum. Okay, so now now they are actually going to create some harmonic series. Why are they going to do this? I guess we'll do it. I don't think I give you any homework problems involving this stuff, and I'm not sure it's all that important. I'm trying to remember who I give you homework. Did I even have a homework? I don't think I even have a homework for this one in MATLAB. Let me check. My open math, rather. I don't. What the heck? What is this? Okay, what did I just do? I don't know. Stop share. It doesn't want me to do anything but share my screen. There we go. Okay. I just need to go and see what we've got here. So we don't, chapter 8, chapter 9. So we don't actually have a homework for chapter 11. So let's take a look at the homework for chapter 11, because if we can just skip this stuff, I might just do it. Yeah, I'm not really interested in this. So I'm going to just give you the quick overview of what's happening here in sections 11.1, 11.2, and not really get into the details of what's going on with the example code that they give. And the reason for that is because they're doing, first of all, they're doing some math, which is maybe a little bit beyond what many of you have maybe experienced if you've not done things like harmonic series and other things like that. But what they're doing is they're doing some mathematical things to demonstrate the abilities of these different types of number types. Most of the time, if you're going into engineering or science, you're just going to leave it in double precision floating point and call it good. There are a few situations where you do something different, but not many. So I wouldn't worry too much about this stuff that's in these two sections. And then also in section 3 and 4, I'm actually going to skip as well. In section 3, they do all integers, which is really important when you're doing quantum mechanics, and really important when you're doing statistics maybe, but it's not really that important outside of some very specific fields. So if you ever go into those fields, you will get plenty of experience learning that in those fields. Not really a good idea to waste time on it now. Then complex numbers, I've decided to not do anything with complex numbers in this class, since it may be a little bit past the math experience of some students. So getting through all of that, we go all the way to page 405, realizing now that MATLAB has a lot of abilities to do things with lots of different types of numbers. Well done. Now, we move on to section 3, character and string data. We've already done this a little bit in MATLAB, and that is to save strings and characters to variables. We've done this before, and now we're going to see how it can be used with arrays and how it can be stored, how it can be manipulated, how you can actually work with it. So go back to MATLAB. Let's clear everything. Why can't I do this? Okay, there we go. And so we're going to start off with H equals, and we're going to qualify this, or we're going to call this a string of characters. So to do that, we have to put quotes around it. Now, when we put quotes around something, MATLAB realizes that these aren't supposed to be numbers. These are supposed to be actual characters, because MATLAB has numbers assigned to characters. It knows the difference, in other words. Go ahead and plug that in there. Now we have this thing over here, which is called a character array. It's a 1-by-1 single. So characters are usually put in single precision, because you don't need that many numbers for characters. There are only a certain number of characters out there. But it is a 1-by-1 because when you open it, it only has one entry, and that is this string of characters. Now the string is 1-by-5. You notice here that it says 1-by-5, and over here, if we can do it. Oh, it does say 1-by-5. Okay. Well, it's only put it into one, so it has one string. So if it's considered a string, it's 1-by-1, and it only has one. Or if you consider it as an array, it's only 1-by-1. But if you're looking at the actual characters, there are 5 characters in here. Each one of these characters being represented by a number to MATLAB. MATLAB remembers characters as particular numbers. And this is now a character array. And it's over here, you can see it's a CH. Instead of being 4 squares, it's just 2 with C and H in it for character. And that's great. We can actually now do a lot of the things that we do with other arrays with this. So we can actually call out a particular part of this string. So if I do H parentheses 5, it's going to ask for the 5th character of the string, which happens to be y. You can do that. And you can define another character array here. This one we're going to call this MATLAB. Right? And now we have this next character array called J. And if we hover over it, it's now 1x6 character, right, in a string. What do they want to do with this next? Oh. So then we're going to, this is actually the thing that I was thinking of before. Now we're going to assign K, a third array, to equal a string character, a string of J. So we made a string array. Hover over up here. Now this is still looking like a 1x1 character because it still is a 1x1 character. But notice that this puts this string MATLAB into the first element of this matrix or this array. So this is actually like a string matrix. And it actually has opened up all these other spots so we could add more things in. So that's one difference there. Gives you a little bit extra capability there of messing with it. So that's the difference between the string array and the character array. Even though they if you hover over them, they both are called character arrays because they both have characters in them. Let's see if I can actually do it. So this one is considered a 1x6 character, and this whatever one, I must have added something to that on accident. But no, it's 1x5. This is 1x6. So this one is 1x5. Anyway, even though they both when you hover over them, they say character arrays, that means they both have characters in them. But this one is considered a string. It looks a little different when you open it than the character array does, and has slightly different capabilities. All right, so let's see. You can also concatenate these arrays. So we're going to say L equals, and we're going to put, now we're going to create, we're going to use these curly brackets. And we're also going to call this, we're going to create a string array. And we're going to use these curly brackets inside of it. And we're going to put in H, and then comma, and then we're going to put in quotes, Stephen, single quotes. So what it did is it combined the character array H with the character array Stephen that I created inside of there and put them one after the other and make it a string array. So now Holly's in the first row, Stephen's in the second row, and so on and so forth. Now let's see if we can do something with this. I'm just curious. I don't know if I can actually do this, but I'm going to try to find out. I'm going to put in some numbers below here. It looks like it's going to let me do it. So press enter on that, close it. And now this is a 2x2 string array that has names and numbers in it. But these numbers are not, they're not numbers to MATLAB. To MATLAB, they're characters. So if I try, so those things are in the third and fourth spots in this array, or actually the second and fourth spots in this array, or they're in row one, they're in row 2, column 1, and row 2, column 2. So I could actually say L, and actually here it shows them, L21 is this and L22 is this, right? So if I say L21 plus L22, is it going to add them together? And it does, but look at the answer. Is that the sum of 56 plus 89? It's not. What it's done is it's just put 56 and 89 together and made it into a string. because MATLAB doesn't realize that I wanted to add them as numbers, because it doesn't see them as numbers. It sees them as characters. So it's just put one character and next character and next, it's just put them one after the other. So this is the difference here between strings and numerical, string arrays and numerical matrices, is the way things are stored and the way that MATLAB perceives these things. Now there is a way to do the math here. You just need to convert them from a string to a number. And we actually have that. That function is called string to num, I think, or something like that. If we do string to num of L to 2, it will convert. I think that's the code. It'll actually convert it to the number 89. Now that's a number, 89. So I could do the math. I could convert these numbers to strings and then do the math. But because I defined this as a string array or a character, when you define something as a character array or a string array, anything that you enter into that will automatically become a string of characters or just characters. So you have to be aware of it. All right, now. More of this same kind of thing. Let's see. Let's clear this out. Yeah. Okay, so if I type in the code AA, what this particular command double does is it tells me what number is associated with the character A. So there is a number that is associated with the character A, and MATLAB knows what that number is. Now I want to know what it is, so I hit return on this, and it tells me the number is actually 97. So if I plug in, if I plug in, quote A quote, MATLAB perceives that as a number, but it's a particular number with a qualifier on it that says this is a character. So it says, oh, it's character number 97. And then it goes and uses that, right? It goes and it displays the character A. It uses that number to display the character A. So you can actually, you can also call the character using the character command, CHAR. And if I call character 97, it tells me that's A. And guess what? Character 98 is B, and character 99 is C, and so on and so forth. And you can just pick a random number, pick character 998. It turns out that that's a B that has a weird font and color to it, right? There's actually there's lots of these characters out there. I don't know exactly how many, but there are a lot of them. MATLAB stores all of these, understands what they all are because it's got them stored and it can recall them all. You can also create an array of characters by doing what they do here about 2/3 of the way down page 406 is where we're at, in case you're wondering, in case I didn't say that recently. So I'm gonna create an array where my first element is a string, because I've called it a string, and then my second element is a number. And it actually returns this as AB, because it's going to assume that this is a character array because I put a character in there first. I actually don't know what happens if you do it the other way. I've never tried it the other way. Let's try it the other way. What if we put in 98 and then A? Does it still assume it's a string array? It still assumes it's a character array. So if you put a character in anywhere in the array and then numbers, it turns out it's going to assume that it's a string array, a character array. I assume that you can force it to do it the other way around, so it forces the number into the character into a number, but I'm not really sure if you can. I just assume you can. So if you make any array with a character in it and a bunch of numbers, or multiple characters and multiple numbers, it will convert all the numbers to characters for that array. Let's do this one. I've never done this one before either. I just thought of it. Yeah, you can even do it in a column and it'll do the same thing. That's interesting to know. Here's an interesting one. If I take the character A and I add 3 to it, or subtract 2 from it, or something like this. If I subtract a number from it, because there's a character in this math, it assumes you're doing character math. So it turns out that the capital letter A is actually 65. Subtract 2 from it and you get 63. And if you want to know what character that is, then you just do character 63. Turns out to be the question mark, right? So if you add 3 to it, you get something else. And so now why is this, why do we even care about this? This actually can be very useful in programming, once again. For example, one of the things that that I use MATLAB for, that I've used it for many times, is for naming files of data. I'll get 40,000 files of data from a tower that I have out in the field here somewhere. And maybe I'll get 40,000 a day. I actually had a tower out here that was giving me like 50,000 files of data every day. It was giving me so much data. And I wanted to name them, but I didn't want to go through and name each one of them. That's not fun. And it's just not really even possible. It just takes way too long. So what I did is I wrote MATLAB code that would take the file and it would look at the last file that I had read in, that I'd named, and it would name the next file with the same name, except it would add another letter onto the end of it, or another number, or something like this. And sometimes it was a letter, sometimes it was a number. But in MATLAB, you can do either one. You can increase the number every time, or you can increase the letter every time. And then you can actually tell it when it gets to the end of the alphabet, it goes all the way A through Z. Then you go through again and call it AA, and then BB, and then CC, and then DD. Or you can even tell it to put a timestamp on the file name with the date and time, because MATLAB knows how to do that as well. So this is a very useful thing. And of course, you're using loops and other things to do this, this kind of programming, but it definitely knows how to iterate or to change the character every time you go through. This is also good, believe it or not. Maybe I shouldn't tell you this, but you can use this for decrypting. Decryption codes work this way. If you're trying to decrypt somebody's password, for example, and the password can be any number, any letter, any character, any this, any that, any this. This is necessary. You have to be able to iterate through each of those possibilities, one at a time. And there are smarter ways to do code decryption, but if you really don't know anything about the password and the password is truly random, this is the only way to do it. If I'm trying to decrypt a password from a particular person, and I know some things about that person, then it might be smarter to use some of the things I know about them to guess at the passwords. And that requires a more complicated program, but you will probably get the password that more quickly. But if you choose a truly random password, then the only way to do it is to just step through every single possibility one at a time, one after the other. And so you have to assign letters, names, and character. You have to assign letters to numbers, and you have to assign characters to numbers, all the different, punctuation characters, and capital letters have to be different numbers, and everything else has to be a different number. And then you can see how the realm of possibilities increases so dramatically when you have so many different options for every single thing in your password. And it can even be worse if you don't have a certain number of letters that are required for your password, because then you have to figure out how many letters are in the password as well. So it can be even more complicated. But that is the gist of decrypting anything, is to know what all the possibilities are, and then to start running through them. Sounds deadly boring, but it is actually quite interesting to write code to do that. Okay, so now that we're done with that section 11.3.2, we're going to start using these arrays for a little bit. We're going to do a little bit of code work here. So let's go ahead stuff out. We're going to make an array. Looks like an array of names. M equals this array. We'll start with Steve, and we'll have Meg, and we'll have Dave. And we'll have Mike. Dang it, I keep doing that. And we will have Heidi. All right, so there's our array of names. Dimensions of arrays being concatenated. Oh. All these names have to have the same length in order for this to work. No, yeah. So yeah, well, so that's what they wanted to show. That's fine. Okay. So we were going to actually change each of these so that they we're going to change each of these so that it actually has the same length. Now, you could do this a couple of different ways. Each one of these has to be the same length because it's storing them as a group of, it's storing them as a string of characters, but each of those strings of characters defines one of the dimensions of the array. Since this one's 5 and this one's 3 and this one's 4 and this one's 4 and this one's 5, they're not all the same. It doesn't like that. So it wants them to all be the same. One of the ways that you can do this is you can actually just add some spaces in here. To Meg, I add 2 spaces. That makes it 5. To Dave, I add 1 space. To Mike, I add 1 space. And then now it works because each one of them has some spaces in there. There's a shortcut to that, and they show that shortcut at the bottom of page 407, where they just put the character command in front of these. Put it in parentheses. And one thing that the character function does is it will automatically put those spaces in. That's literally what it does. It just puts in extra spaces. So I'm going to take out the spaces, and the character function will put them back in. Nope, that's not right. Oh, that's because I shouldn't have it in the square brackets in there. Square brackets need to come out because it's already going to, it's going to automatically build the array. So and it's also not capital C. Lowercase c. Actually, it might even work with the square in there now because it might do an entire array at once. Let's see if it will work. Nope, doesn't like that because it won't do an entire array at once. It has to do these each individually, and then we have to put. I'm not sure if we actually have to put commas in between them, but I think we do because I think the character array is expecting commas, not anything else. Why can't I put a comma in there? Because I'm pushing the wrong button. So now, so the first one that I built was actually a column array of their names, but it didn't work because, you know, I didn't like it. So then I made a column array of their names with spaces in between, and that created a column. Now this one is actually going to be in a single row with multiple columns. No, maybe not. So it actually will make it into columns automatically. Well, that's fine. I figured it would make it into rows automatically, but it makes them into columns automatically, which is fine. And we can actually, we should be able to invert that. But notice that it doesn't invert it name by name. It inverts it character by character, right? So now Steve is here and Meg is here, but the first name now is SMD Much, whatever that is. Right, so it kind of, and it puts the spaces in too, so it makes things kind of weird. But it still has Steve here and Meg here and Dave here and Mike here and Heidi. It's just not what you would expect it, how you would expect it. So anyway, the point being with all this is that MATLAB can manipulate characters in many similar ways that it manipulated numbers. Excuse me. Here, let's do this. We're going to jump over here to page 408. Another command is the string command. So if we do n equals string, and then inside this, we're going to make, so whenever you make an array of strings, an array of characters or an array of strings, well, particularly an array of strings, you use these curly brackets inside or on the outside of this string array. So here we're going to do Steve again, and we're going to do Meg, and we're actually going to do this with semicolons and Dave and Mike again. And Heidi again. So that's another way to make this array. It's now going to be called a string array, right? And so it's going to consider each of these names as a string of characters. And now this has 5 rows and 1 column instead of the 5 columns that the character array had. So it's considering each name to be an individual entity instead of each character in the name to be an individual entity. And this one, let's see what happens when we try to invert this array, when we try to take the, so this one actually does put each name in its own box so that it turns that column of names into a row of names instead of a column of characters and row of characters. So a little bit different things here. Now, hopefully you can start to see how we could put titles into an array, titles of columns or titles of rows, because you can put names, you can put words into an array. It doesn't have to be names, it can be any words, of course. Okay. Let's see, let's do this thing here. We're going to now store into an array a bunch of numbers. We're doing 84, and we're doing 10, and we're doing, no, we're doing 100 rather. And we're doing 88, we're doing 95, and 100. So there's just a number of regular old numerical array, numerical matrix, whatever, however you want to call it. And we can actually do this thing. Let's see what happens here. We're going to define a new array. We're going to call it results, and we're going to put in M and P. Maybe not what we were looking for. I'm assuming that these were the results of a test, and we put them in the same array. And so it's what it did is it assumed that everything was a character, and now the 84 became a capital T, the 100 became a lowercase d, the 88 became a capital X, the 95 became an underscore, and the 100 became a D, lowercase d again. And that's maybe not what we want. So maybe we want to do a num to string again. Just killed something. So we'll say Q equals num to string of P. So now those numbers are now strings, right? We changed numbers into strings. What was the last one? Did I do a string to num last time? Yeah, I think I did. But anyway, these numbers are now strings, and now we can actually add them, put them together in the same array. Results equals M comma P. But we're not going to use P, we're going to use Q, because it's now called Q. And now we can see we've made kind of a table. You know, it's a very simple table, but it's a table of names and scores, right? Excuse me. Actually, would like to, if I was going to do this, I would probably do this. Results equals M, comma, and then I would probably put in a something in between here, like a space dash space in string, and then put in the Q. Doesn't like that because it's not consistent. So I'd have to do that with, if I change that to string, see if this works. No, didn't like that. Well, anyway, the way that they did it, because they spelled out the names all the way, actually worked out fairly well because they got that little space in between. I didn't get a space in between mine, which is what I was trying to change, but that's okay. Whatever. You can also do this using the display function, which we've been using for quite some time now. You can just display the array M comma Q. Anyway. So anyway, oh, I know why that previous one didn't work. Because it doesn't have 5. It needs to have 5 rows. It doesn't have 5 rows of space and I'd have to create an array of spaces and bars to do that. But anyway, okay. So yeah, let's do something. Let's do something new with this stuff. I'm going to create a for loop. We're on the top of page 410. For k equals 1 to the length of p. Remember, p is that list of results or scores or whatever. So we're going to do this thing over and over again for every element that there is in that array p. I'm going to do f printf Now, what does this mean? Do you remember? Doing M. This is usually really difficult to remember how these functions work, but let's try to remember what the fprintf does. So the fprintf takes something out of an array and prints it to the screen. But you have to tell it what to take out, and you have to tell it what it is that you're taking, what kind of thing it is you're taking out. So the thing that you want to print out to the screen is going to be in quotes, right? And in this case, I'm just printing out 2 things from here. I could also print words in here. I could actually say the student named, oops, Apparently I can't because I'd have to start over again. But anyway, um, I could actually type in here the student named and then put a space and then put this %10 and then this %8 or whatever else. But regardless, when you put the % in there, that tells you that you're taking something from an array. The first time you put a % in, you're taking from the first array that you put over here. And the first array that I put over here was M, and I'm telling it that I want it to take the kth row, all of the columns. So and the first time it goes through, it takes the first row and all of the columns. And then the second time it takes the second row and all the columns. And the third time it takes the third row and all the columns, so on and so forth. And then the second thing that I'm taking out is a number. This % 8.0 means that it's going to be, I want, and well, sorry, the S means I'm taking out a string. So that means I'm taking out a name. That's one of the names. The second one is I'm taking a floating point number from P. And that floating point number is going to have 8 significant figures, essentially. And then I'm going, at the end of it, I'm going to use this /n or \n rather, which means new line. That takes us to a new line. So that was all code that we learned about in the input and output chapter, right, from fprintf. And that's how it's done. So let's see how it works. Let's hit enter. So the first time it went through, it took the first thing in the first row and all the columns, which means all of the letters, essentially all of the characters, took all of the characters in the first row and printed them to the screen. And then it took the number in the first row of the second matrix and printed it. And then it did it again for the second row name and the second row number and the third row name, third row number, did this all the way till it got to the end of the length of P, which is, 5. So I did it 5 times and then it ended. Now, if I wanted to do this again, I could do it again like this. And then I could actually put in some words here if I wanted to. I could say the student named whatever this name is that I pull out first, received a score of this on the physics test, period. Wahoo. Right? I could do that. So you can actually print out other words as well. And then it'll just put them into sentences like this. And this actually this is very similar code to the code that I used to name file names when I was saving files. I also had to have something in there to save the file to a place and to extract the file from a different place. But anyway, the point is that I can actually extract things from the file itself to give it a name. So oftentimes the data files that I would get from the field, the first line in the data file actually gave me a date and a time. So I could actually just extract that date and time and put it in the name of the file. And it would all, and then all my files would have a different name based on date and time. Then I can organize them by date and time. And I could do all that by computer automatically by just writing one piece of code, and it would do 100,000 files for me in a matter of minutes, which is a great thing. Saved me a lot of time and pain. So anyway, the usefulness of computer programming. Let's see what else here. What are they doing next year? Here they're just doing a different version of this, I guess. Do I have? Yeah, I do have it. So if we want to just display these two things just by writing them down, we can use 2 string arrays and just combine 2 string arrays. We're going to say that R is going to be equal to the combination of these two, or the concatenation of these 2 string arrays, N and P. N and P? Yeah. So we're putting N in the first row, a P in the second row, and this is what it results. This is the result of it. Sorry, first column, second column. And then we can use the fprintf again, actually. And instead of using the fprintf on two different things, we can use it on one because we just made this array that we called R, right? Did we call it R? Yep. So we can actually just call R here. And this is what they're doing. And this time we're taking two strings out. So we just need to have two 10-character strings. Not 80 characters, 10-character strings. And we can just put them together here. And we could actually add in, so what I'm gonna add in right here a tab, which I think is \T. Let's try that and see if it works. Yep. And oh, that didn't work. Not what we wanted to do. What is \T? I don't know what it is. If it's not tab. Oh, it still did this. And I'm going to redefine R to do this because I think that this might fix. Nope, that still gives me the same kind of issue. Oh, I think I know what I did. I'm going to transpose that matrix, and then I'm going to fprintf it. Still giving me the same problem. Oh, it's because I didn't do it. There we go. All right, that might do it for me. There we go. So you have to transpose it to get everything in the right order. And then I'm going to try to do the tab. Let's see if the tab works. \tab. That should spread them apart further. So there you go. Okay, we're getting through it. Slowly but slowly. All right. So here they're actually talking about when you're loading data files and you want to give them file names. So this is an example of that. They show you all the examples. I don't actually have a file of data that we can use for this. I don't think, but they show you how to do this, where they're using a for loop and they're creating the file name, and then they're going to save it. When they save it, it actually saves it as an actual file in the current folder over here, and then you can do whatever you want with it later. But I'd have to think about if I can grab some data. I'll think about that. So anyway, that takes us through section 11.3. And let's take a little bit of a break here. Take maybe 5 minutes or so. Go get a drink, whatever you want to do. We'll come back and hit the rest of this chapter and then be done. Oh. All right. Back to the grindstone. All right. I couldn't think of any data that I could use to demonstrate this, but hopefully you can see how this would be useful in naming data files. Like I said, again, the code for doing that you can find starting essentially at about 2/3 of the way down page 410, all the way through 411, and then also a little bit on 412. So it's weird that they have a bit of them in 412. Anyway, moving on. Let's clear things out. All right. So now we're going to go on to symbolic data. Now, symbolic data is essentially a storage of mathematical functions. So MATLAB does have the ability to actually to actually store things like x+4 and recognize it as some kind of algebraic function. I'm not going to ask you to do this, and I'm not going to do it myself because I don't think I actually have the symbolic toolbox. But you actually have to have the symbolic toolbox added to your, or loaded in your MATLAB, and I don't think I ever did that. I can check, I suppose. This command tells MATLAB that x is going to be a symbolic is going to be a symbolic variable essentially, and so because I don't have toolbox added, it doesn't know what to do with that. So anyway, so we're not going to mess with that, but we can also do logical data, and logical data we can mess with. So logical data is true, false, 1, 0, yes, no, those kinds of things, right? And they're all represented as zeros and ones. And of course, 0 and 1 is very easy for MATLAB to recognize, as it is for all computers to all computer programs to recognize. But MATLAB also recognizes the word true as a 1, as long as you are using it properly. So we can actually create an array of trues and falses. This is near the bottom of page 413. You don't have to put any quotes around them or anything else. You just write the words in there, and MATLAB recognizes the word true, false as 1, 0. True and false is as 1s and 0s. So you can just put in there. Automatically calls it a logical array over here. It gives a check mark in a box. That's what the logical array is, right? It also is recognizing that you actually entered them as characters, And so if you double click on this, you're going to see them as ones and zeros, but it recognizes the fact that you put them in as characters. So that's fine. Now I've actually gone in there and opened it and closed it and not changed anything. It's actually going to recognize it as truly logical array because I didn't tell it otherwise. So MATLAB knows this stuff already. It has it all built into it. You can also build a logical array by calling a logical function of some kind. Logical functions are usually functions that have some kind of a qualifier on them, or logical operations rather, not logical functions. But logical operators usually are asking a question with some kind of condition. They're a conditional thing. And so if we say x equals 1 to 5 like that, create an array this way, which is just 1, 2, 3, 4, 5, then we can set up another array that's got also 5 numbers in it, just whatever numbers they are. Sure, why not? So that one has also 5 numbers in it, but they're 5 very different numbers. And then I can use a logical operator to create a logical array. So I can say that Z, which is going to be my logical array, equals all of the things where X is greater than Y. And what MATLAB does, and like we've learned before, is it goes through X and it compares it to Y, and every time X is greater than Y, it puts a 1. Every time X is less than Y, it puts a 0. So if I run that, it tells me 0, 0, 0, 0, 1. Because X is not greater than Y for the first one, because X is 1 and Y is 4. For the second one, X is not greater than Y because it's 2 and 4. The third one is not. The fourth one it's not. The only one where X is greater than Y is the last element in each array where X is equal to 5 and Y is equal to 1. And now Z has been automatically made into a logical array. Notice that when I first put my thing on it here, it says it's numerical, and I'm going to open it up here. It still says it's logical. And if I put it back there, it's going to say it's logical again because I've confirmed that it's going to be. So MATLAB has this kind of grace period where it's kind of deciding what the array is going to be, and then you can actually change it pretty quickly then by adding other numbers or changing something in the array. But if you don't do anything to it, if you open it up and don't do anything to it, or you just don't do anything to it at all, after a while it will kind of finalize its decision. Doesn't mean you can't change the type of array it is. It just means that MATLAB has decided what it's going to treat it like for the time being. All right. So here's another interesting one. If you use the find command, the find command also allows you to use qualifiers, to use these conditions. If I find all X that is greater than Y, like this, it does something slightly different. It actually is just it's going to go through number by number, and it's going to return the first number and every number after that. Actually, it'll return every number in X that is greater than the corresponding number in the same place in the array as Y. In this case, it returns 5. But notice this number is this array that it's stored 5 in, the answer in, is not a logical array. This is just a number. So the find function, even though it does use the same kind of conditional statements here, is not going to return a logical array because it's going to return the number like the find function is designed to do. Just so you know, there are other arrays, there are other functions like that that use the qualifiers, that use the logical logical operators, but return numbers instead of logic arrays because the way they're designed in the function. All right. So the next section is actually kind of goofy for what we're doing, but it's important, especially for it's important for computer scientists particularly, and people doing high order math kind of stuff, because it saves memory. We don't really care about it, but what this next part is called sparse arrays, and sparse arrays will take a very simple array, like an array completely full of zeros, an array completely full of ones, or an array with ones down the diagonal or something like this. Arrays that are extremely simple, and it converts them into an array that doesn't take up as much space. In other words, all those zeros in the array can be like, you can store them as smaller floating point numbers, or all the ones can, if they're exactly one, you can store them as integers or whatever. You can store them as much smaller value data points so that they don't take up as much data. And that's really important when you're doing big calculations, high order calculations and things like this. Not all that important for us, but MATLAB is capable of cutting things down. This is, you might think of this as similar to taking a piece of music and making an MP3 out of it. What MP3 is, an MP3 is a condensation of music. You have this music file, which is humongous, and you cut it down into a little computer program that has most of the same information, and then you can put that into an MP3 player and you can hear your music. Now, MP3s do not give you the same quality as like a record does. A record will give you much higher fidelity than an MP3 player ever could. But you can't carry a record player around in your pocket, so you switch to MP3. If you're wanting to look at the math in high precision, you don't want to do this. But if you're trying to do the math very quickly and you don't care if you lose a little precision, it's okay. It's the same as listening to music. If you want to listen to really good music, really high quality music, you never use an MP3 or a CD. You use either a tape or a record, because that has the actual sound that was recorded. And those are really, I mean, you have all kinds of tape and all kinds of record, but it has to be analog tape and analog record to get the actual sound recorded. The only other way to do that is to do it with a huge, well, I can't think of any other way to do it. It really has to be an analog magnetic recording on tape, or an analog physical recording on a record where they actually make dents in the plastic or whatever. There's no other way to make an analog recording besides doing one of those two things, as far as I know. And so if you go into like big time recording studios, there are very few musicians that actually record analog anymore because they don't care about the quality of their music. But jazz musicians happen to care a lot about the quality of their recordings. So if you go into a jazz recording studio, they're still using magnetic tape and sometimes even records to record their music, because it gets all of the nuances, all of the actual quality of the original performance of the music. And it costs a ton of money and a ton of time to do it properly. But then you get an actually good recording. If you go into somebody's house who actually spends money on, like, they're an audiophile, in other words, they spend a lot of money on high fidelity stereo equipment, they will have a tape deck, which is usually a reel-to-reel tape player, and they will have an actual really good high-end record player, and they will not have any DVD or CD players or MP3 players, because there's no point in playing an MP3 on a stereo system that's worth $500,000, which is what those stereo systems can be worth. In fact, just the speakers can be worth $500,000 for those kind of stereo systems. If any of this interests you, I'm an audiophile, but I can't afford that equipment. But if any of this interests you, you should check out the website for the best speaker company on the planet, without a doubt. I've actually been to their factory and listened to their speakers next side by side with all the other speakers that compete with them, which are companies that most people have never even heard of. But this company is called Wilson Audio, and Wilson Audio makes the best speakers for replicating actual sound, real sounds, what they were supposed to sound like in the world, and they're amazing. And you know, $500,000 for a pair of speakers. Can you imagine? That's what like the big movie companies like Pixar and Disney, they actually use their speakers in their studios because they're that good. Anyway, just a little aside there. So that's what they're talking about here, is converting big arrays into smaller arrays when it doesn't really matter for the quality of your calculation, just to make your program work better. We don't need to worry about it too much. But moving on to categorical arrays. So in these last sections, we have categorical arrays, cell arrays, structure arrays, and table arrays. I'm pretty sure that each one of these types of arrays is going to now put different kinds of things into the same array. So they're used for different things. But I think that every single one of these does this kind of thing. It's kind of a mixture of things. It might be numbers and strings, or logical and characters, or whatever else. But I'm pretty sure all of these do this kind of thing. So just keep that in mind as we're going through these last few sections. And these are very useful when you're trying to make something like a user interface, where you're giving somebody choices. Those choices correspond to maybe numbers, or maybe words, or maybe they correspond to some kind of a turning off something on and off, so something like a logical something or other. When commands that the user of the computer are going to do something in the program besides math, so it's actions besides math in a program, essentially, and it can also include math. So anyway, we're going to start with categorical arrays. So in a categorical array, we're going to have an array that's going to store whatever information you want to store into it, but it's going to put it into categories. That's why it's called categorical. So we're going to start off here on page 415, and we're going to clear things out here a little bit. We're going to start on 415. We're going to build our first categorical array. We're going to call it W, for lack of better. And we're going to use the categorical command or categorical function to do this. Categorical, there we go. And we're going to have parentheses on the outside. And because this is an array of stuff rather than just numbers, we're going to use our curly brackets on the inside, as I've mentioned before. And inside of here, we're going to create, we're going to put in these different elements of the array. I'm going to start off with a capital A. Oops. Capital A. And then we're going to do a capital C. And then we're going to do a capital D. And then we're going to do a capital E. And we're going to do a capital D again. And then a capital B. And a capital A. And remember that capital versus lowercase does matter when you're doing strings and characters. It certainly means something different to MATLAB. So now we've created a categorical array. Notice that it's got a different symbol up here again. If you hover over it, it's saying that it's a 1x1 double to start, but then eventually it'll change it into a categorical if we wait long enough. But anyway, so this is a categorical array. So then I'm going to go down here and I'm going to actually ask it to tell me the categories of W rather. W, there we go. And what it's going to do is it's going to go through and look for things that are alike, right? And it finds a couple of A's, so it calls that a category. It finds a B, but there's only one B, but that's okay, it's in its own category. It finds a C, it calls that a category. It finds two D's, it calls that a category. It finds an E, calls that a category. Now this can be extremely useful. Again, this can be extremely useful when you're taking data. If you're taking data and your data is coming out in terms of characters, or it's coming out in terms of colors, or it's coming out in terms of whatever, you can actually start to organize this. You can say, well, what kind of categories do I have from taking all this data? We have a blue category, a red category. Can you imagine writing a program for sports like this, where you say, well, I'm going to have one category that's going to be 3-pointers, one category that's going to be 2-pointers, right? And there are programs like this all over the place. There are apps that are written for keeping score in sports. There's apps for keeping track of yardage in sports or whatever else. And there's all kinds of categories that things are split into in these kinds of programs. So this is where this can be very useful. You can also use the find command. We can say, let's find where W, something in W is equal to double equal sign, because we're using logical operator equals A. We want it to equal the category A. Well, where in W is there an A? There's an A in the first element and in the 7th element, right there. Apparently they have 8 in theirs and I only have 7. That's all right. I missed one of theirs, but that's all right. So that is a categorical array. Categorical array is storing things in an array, and then you can extract categories. Now I believe I do not think that a category array has to be strings. I think that it can be anything that you put into it. It can, so in this case, characters. I think you can put in strings. I think you can even put in numbers. I think you can put in other arrays into categorical arrays, actually. So I think that you can put just about anything into a categorical array. Trying to think of a way we could test that. Well, we could just create a new array W and see if it works. I'm not sure if putting numbers in with strings would work, but we'll try it anyway. Because I think it'll just turn the number into a string, which is fine. No, so could not find unique value. Cell array input must be a cell array of characters. So it does have to be characters, but you can enter the numbers in as characters. So if we put quotes around these, and then we did a num to string thing, we could, or string to num rather thing, then we could change them back. But I believe that you can do other arrays of characters. So it turns out you do have to use characters in this one. So there's another kind of array. Let's do a time array. This is page 416. If I do year equals 1990 and 2016. This just comes out as a number array, just like this, right? So this is just a 1x7, or sorry, 1x2. That one was 1x7. This is 1x2 double. So this MATLAB is just treating this as 2 numbers, whatever, you know. And we can do the same thing with the month. We can say the month equals 2 and 5. And we can say the day equals 1 and 20. They're actually doing columns, so I have to do this differently. I have to rewrite my month one as a column array. All right, so now we've got, and I did the day one wrong too. That should be a semicolon, not a, there we go. But then I can actually use this function called date time. So x equals date time. And I can put in my, you see it's year, month, and then day. You put in your year first, your month second, and your day last. And it actually knows that those numbers correspond to days months, and years. Of course, you put it in year, month, day, and then it spits it out as day, month, year, whatever, right? But again, this is useful when you're doing things like naming files or storing things or sorting things or whatever else. Very, very useful. You can actually use there is in these arrays where we're using the date time function. You can actually sort things by the date. It actually knows how to do that, and you can even add time into there. For the time, you put in for the time, I believe you put in hours, minutes, seconds in that order, I think. So you would do something like 12, 24, 45 or something like this. Yeah. So you can do time as well in there. And yeah. I've never seen this function before. Oh, yeah, I can do this one. So if we go back, so this right here, yeah, that's our X array. Okay, so we can actually, we can do some math with this. So if we're going to define, this is also on page 416, yeah, 416. We're going to define y to equal the difference between these 2 days. So we do the difference in x, right? It'll actually tell you what the difference is. In this case, it's told me the difference in hours, right? Hours, minutes, and seconds. It doesn't do it in days, and there is a way to do it in days, and I can't remember what it is, but there is a way to do that, or to convert it to that. There's also, you can also just do the math. You can say that you can say x1 minus, let's see, minus x2, I believe would do it for us. Yep. But I did it the wrong way. I did the first day minus the second day. You want to turn that around to do the second day minus the first day if you want it to be a positive number. So you can also, let's see, you can also do this, I believe, or you can take the difference between the 2 days and multiply it by 10 to see what 10 times that difference in time would be. And it'll do that as well. And I can't remember how to convert it back to days. Let's see if, oh yeah, it's convert from. So if I do date time, and I do y, comma, convert from, and then I do comma what I want it to convert to, which is years, nope, this. Nope, not the right size. Let's see. Time is in. I'd have to figure out how to do that, but you can do it. Here they actually take some climate data and they make a bar chart with it. It's pretty easy to do that once you've converted that data into you've got dates and times in one column, and then temperatures in another column. Then it will just actually make a bar for each day, and if it's different times, it'll make a different bar for each day and a different time. Either way. So again, very useful for dealing with data. All right, so the next section we've actually discussed. We discussed this, I don't remember when we discussed it, but you can actually create arrays that are more than 2 dimensions. You can do it a couple of different ways. Let's clear up things here and try first way. Let's make sure that this still works in MATLAB. Used to be able to do it this way. But if I want to create an array of numbers that's 3-dimensional, if I wanted to do 2 dimensions, then I just did like 12 space 23, 42, something like this with a semicolon, and then I put the next row in, right? 12, 34, 5, 2, 1, or whatever, and then I'd have my 2-dimensional array, right? See, I can't remember the old way to do it now. Well, that's all right. I can't remember the old way to do it, and I'm not even sure if it works still. But they actually have a function for this now called my3D array, right? So what we're going to do is we've got this array X defined as theirs is 3 by 2 or 2 by 3. So maybe I'll change mine to be theirs, so that's not too confusing. So theirs goes like 1, 2, 3, 4, 5, 6. And then 4, 5, 6. So there's their first array, and that's great. And then we're going to define y to equal this 10 times x. We'll just put that in there. And then z to equal 10 times y. Times y. And w to equals 10 times z. So now we've got, oh, that's capital W, oh, whatever. So now we're going to use this function called my underscore 3D capital D underscore array. And this is an actual function in there. So what we're going to do is we're going to use this semicolon, and this actually is the same, we're using the semicolons in the same way, or the colons in the same way as we did with colon notation, but it's not immediately obvious. But let's go ahead and just do it first, and then we'll try to explain it, try to understand it. We're going to say that this is equal to x. So what does it mean when we say this is equal to x? So we're creating an array. We're gonna call it. It's going to be called my 3D array. And actually, now that I think about it, my 3D array is not a function in MATLAB. This is actually just an array we're making. Yeah, so it's not actually a function in MATLAB. This is actually the old way that it's done. Now I'm remembering it. So this is the way that I learned how to do it. But it's not obvious because they use this wording, my 3D array. I'm going to actually call this something else. I'm going to just call it D, because it doesn't matter what you call it. I'm going to call it D because I don't want you to think that that's a function, even though I thought it was a function. Because I always forget that they do that funny name. I always think it's a function. But it's not a function. What it is we're creating a new array D, and we're going to say that everything in the first row and everything in the first column and everything in everything in all the rows and all the columns and the first drawer. I think they call it a drawer. I don't know if it matters. But anyway, we have to have something new to call this third dimension. In our two-dimensional arrays, we called rows, rows, and columns, columns. But imagine that instead of having rows and columns, we're also having things behind those rows and columns. And the things behind those rows and columns, we're going to call drawers. So for each element in a two-dimensional array, it's like you can pull out the drawer, you can pull out that number, and there'll be other numbers behind it. And that's why they call it a drawer. And I'm pretty sure, no, they call them pages, actually, looks like, on the next page. And that's fine too, but I like calling them drawers because it makes more sense. And in other programs, they do call them drawers. It doesn't really matter what you call them. I mean, call them whatever you want. They're calling them pages. But you have to imagine that you can actually store things behind that. And you can even take each one of those cells and store things inside of that. And you can keep going until you get sick of doing this. But the point is that we're going to take everything that's in the first row, everything that's in the first column, and then the first drawer. And we're going to put X in that spot of this new array, where X is equal to this thing. So that's what we do when we call up this first thing of D. Now we've created D. So what does D look like? Well, D looks like this array, so 2 by 3 double. That's fine. But you have to realize that this is actually inside of an element of another array, which we call D. This is just one, this is actually a drawer inside of D. You could think of it as. Okay, well, that's fine. Now we're going to need to define the next one. So we're going to do the same command again, except we're going to put it in the second one here, and we're going to put something else in there. We're going to put Y in there instead of X. Then we hit return. Notice that it didn't change what D is. I mean, it didn't create a new thing. It just put something else in D. Now D, instead of being a 2 by 3 double, is a 2 by 3 by 2 double. There are 2 drawers in D now. And if you open up D here, you see the first drawer and the second drawer as separate arrays. We do the same thing again for the third one. And in this one, we're going to put Z, I guess. Yeah. And we're going to do the same thing for the last one, which we're going to call a capital W because I hit capital W. And now this is a 4-dimensional array. In each one of the drawers of array D, we have a 2 by 3 array. Each one of them has a different 2 by 3 array. So if we just looked at D without looking at what was in the drawers, it would look like this. Let me write it on the screen so everybody can see. Sorry. If we were just looking at D by itself and not looking inside the drawers, we would see an array that looks like this. And in drawer number 1, we would have X. Here we'd have Y, here we'd have Z, and here we'd have capital W, because I put the capital W in there. That's what we see if we were just looking at D. But then if you open up this drawer, you would see that there's a 2 by 3 array in that drawer. In other words, behind here, there's other things going on, right? You could also make more of these drawers in D and have 4 dimensions instead of 3, right? So that's what's going on in this section. Now, you really can go as big as you want in these. I mean, MATLAB does have its limits, but you can get really crazy with this. And why would you want to do this? Well, this, again, is very useful when you're taking data. For example, I have a field out here. If you've ever driven on the way to McCook, you see this corner pivot. It's a circle pivot that only has a quarter of a field on it, on the corner of Farm Road and 83 going to McCook. Well, inside that field, there are actually over 200 separate fields, 200 separate plots that are all growing different things. And in each one of those plots, there are different measurements being taken. Well, you can see how something like this would be useful for tracking that kind of data, because you can consider the field to be an entire matrix, and each one of those plots in the field can be a different drawer in the field, and each one of those drawers holds a matrix of data for that field. And MATLAB can deal with that so that you can do all the math, because all the math for each one of those fields is the same. When you're calculating the data, the work for the data on all those fields, it's all the same math. So it doesn't matter what field you're in, you're going to do the same thing to every field. So you just put it in one of these big multi-dimensional matrices and just press go, and it does the math for all of it at once. Kaboom, done. It's a beautiful thing. That is the idea of three-dimensional arrays. Now we're going to move on to cell arrays. Well, a cell array is an array where you can store different types of data, and it can also be many dimensional. So this gives us the option of taking that previous section and now turning it into an array of, you can have characters and strings and numbers and everything else. So so how do we do it? How do we make this happen? Well, again, when we're starting to put things in there that are not just numbers, we're going to have to use a little bit different. We're going to, instead of using square brackets, we're going to use these curly brackets things. Whenever we use the curly brackets, that essentially tells MATLAB to be okay with what we type into it and kind of work with it. Still have to be careful to do it correctly. Let's see, what am I doing here? Okay. So, so the quick way to do this is to just put in some of these curly brackets and just put some stuff in. The thing is that you do have to tell MATLAB what each element is going to be comprised of. So if we put in an element like, if our first element is a number, you just put it in as a number. If our second element is going to be a string, we need to type it as a string, like that, right? And let's say that our last element is going to be an array of numbers. We can put an array of numbers, 3, 4, 5, or something like this. Let's see if that works here. So here it's made this array, and it recognizes it's a cell array because I put 3 different things in it, and it treats each one of these things as an individual thing. This is a number, this is a string, and this is the 1 by 3 double. If we open it up here, you can actually see that it's put each thing in its place. So it's put an array in 3. So that's kind of like making a multi-dimensional array. It has an array within an array. Right? You can even get more crazy with this and do something like this: 3, 4, 5, and then 7, 8, 8, 9, something like that. And then all of a sudden you have 2 or 3 by 3 or 3 by 2 by 3 array in here, right? And so this is what a cell array is. And of course, a cell array gives you the option of storing different things together, and they can be correlated. So everything that's in the first row can be related to each other, or everything that's in the first column can be related. You can put names in the first column and dates in the second column and scores in the third column and letter grades in the 5th column and whatever else. And you can actually do calculations. This is how grade books, electronic grade books are done. Where you calculate the grade and you give it assign it a letter grade. It's all done using code. And so this is the kind of thing that you can do. One of the problems with cell arrays is that because you have so much stuff in them, working with them is a pain in the butt. Because there's so many different kinds of things. You can do calculations with different things in cell arrays, but you're constantly converting back and forth to make sure you've got it right. You're constantly having to check to make sure you've done all those conversions correct. So cell arrays are great for storing things and great for calculating things of different natures, but it comes with that downside that they're complicated. The next type of array is a structure array, which is actually very similar to a cell array. The real difference is the way that the data is stored, the way that MATLAB thinks about the data that is stored. So let's see here, what kind of structure array they're going to build here. This actually takes us to this takes us into a realm that's similar to the function handles that we used when we were dealing with writing functions, inline functions, and using function handles. What's the best way to? Trying to think of a better way to do this besides going through all this code, because the code can sometimes be confusing, but that's okay. We'll just go through it anyway. I can't think of a better way to do it. Oops, that's not what I want to do. All right, so starting on page 422, they're going to, no, that's the cell array. Starting on 423, halfway down 423. We're going to create some different arrays. We have a numerical array, just using the colon notation 1 through 3. And then we're going to create a string array, b equals this array with a string in it. A, B, C, D, F, G. Okay. And then we're going to create a specific number array that is single precision. Single precision number array of 1, 2, 3, 4, 5, 6. Close that off. Now, we're going to create a structure array by first choosing a name, and they again use this thing my structure, but I'm just going to call it structure or something. Struct. Call it struct. And structure arrays are going to put everything that you put into a structure array is going to need a label. And you're going to label it by doing this. You're going to say the name of your array that you want it to be called, struct in my case, dot, and then you're going to put in your label. In their label, they call it some numbers because the first thing is just some numbers. I'll call it 1 underscore 2 3 or something like that. So that's the name of the first thing that I'm putting in. And then I'm going to assign that to equal A. So the first kind of box in my thing, and they call it a field. So the first field in my array called struct is called 1 to 3. That's my first field, and it's going to be equal to this array A. It's going to be equal to this thing right here. And then I go ahead and I do this again, and I give it I define a new field. I give it a new name, and I call it alphabet for alpha. I'll just call it alpha for alphabet rather. Alpha. So the second one I'm going to call alpha, and I'm going to let that equal the B thing, which is going to be those letters that I typed in that string. And I'm going to do again for the last one, which I'm going to call, what do they call the third one? I don't know. Whatever. Some letters, some numbers, and more numbers. More numbers. And I'm going to let that equal C. And then when I'm done with this, I mean, even when I started, I created this structure. You can see that structure has a different thing up here, a different little icon. And if we open this up, which we should be able to do, there we go. It shows this structure as a list of things that are in the structure with the names of the fields. So this is the list of the fields. as the name of the fields and as the type of the field, and then it shows you the value of each field. So this is more like just having like a closet full of clothes or something. And the clothes are labeled on the hangers, and you just hang them up on the labeled hanger, and each hanger has its spot. And so if I want to call things from this, I can actually use this same thing here. I can say, I want to know what is the third thing in structure.morenums, and I just type that in and it'll tell me what it is. Actually, I want to do it without that, so it'll print in string. And it tells me that it's a single precision number, and the number is 3. And I can do the same thing for the alpha one. I can say, if I want to know what is the fourth thing in struct alpha, struct.alpha, I can call that, right? I can also just call struct right there. So it just types it out. Types in each field, gives you the name of each field and what the value is. So that is a structure. Again, it's very similar to the cell array. It's stored differently. It's used different, and it's using different code, because here you name each field, and then when you want to call an individual field, you can, which has great advantages. The other one, they're just put into cells, and those cells are essentially numbered, and those cells they call pages, right? Well, no, well, they do call them pages. Well, I can't remember what they call them actually on the cell array. They call them cells, I guess. But you can actually have, yeah. So but those ones are just essentially one after the other. Instead of being named, you have cell 1, cell 2, cell 3. So anyway. Lots and lots of different things here. They do lots of different examples with what you can do with this and how you can do it. The very last type of array is a table array. And we have talked about it once already in this chapter, but in a table array, you're going to have different kinds of, you can put different kinds of things into the array, and it's specifically used for plotting tables. It usually is used in that very specific way. And so you can see the example of it where they do the Orlando precipitation versus date, and maybe also time. They have one date and one time one, something like that. But anyway, so that is that. Now, since I haven't actually given you homework for this chapter yet, we're going to sit down and do that. I'm going to assign you the numbers that I want you to do, and then I will enter them into MATLAB for you to know about later. So let's see. Not really interested in the first section, character and string data. So this in section 2, starting at 11.5, I definitely am interested in you doing some of these problems. Let's do number. Let's do number 6 and number 7. Those should be really easy. And number 8 also should be pretty easy. Yeah, so then number 9 I like as well. Number 9, you're taking a character array, and then you're going to convert those numbers into numbers so you can do some calculations. And then you will actually convert those numbers from the calculations back into characters and then insert them back into the array as a new column of volumes. So you've got dimensions that you're going to turn into volumes. So I like that one. That one's not terribly difficult, but definitely shows you how to manipulate numbers and characters together. I like number 10. That's a fairly common, it doesn't look like a really big deal kind of problem, but it is a big deal kind of problem. Did I ever give you this file called thermocouple.dat? Did we use that file before? No? Okay. In this particular problem, just so you know, in the second and third like little points there that they give, you're not actually going to be loading this file into your program. You're going to be loading a file like this that could be bigger. So you have to actually find out what size the file is first, and then your code needs to extract the data from whatever file you're given. It might have more thermocouples, and it might have more data points. So instead of having 12 or 15 data points like it has here, 12 rows, in other words, it might have 48 rows or 40 million rows or whatever. And you have to figure out how many rows it has, how many columns it has, and then write a program that will extract that data and write it into MATLAB. So not just for this file, for any file. So don't just enter this file in and assume that you're done with this program. This program has nothing to do with entering this data into MATLAB. It has to do with entering a file that might look like this, but might be bigger in both columns and rows, and you have to write the file. So this one you won't even use this data here in your code. It will never be in your code at all. So that's 11, number 10, problem number 10. Let's also do number 13, which is a similar thing, but you're also going to extract dates and with your data instead of just data. So it's similar to that. It has several parts to it as well. And let's do a 15 for multidimensional arrays. For cell arrays, let's do number 18. For structure arrays, let's do 21, and that's it. All right, so those are the numbers I'm going to have you do. I will put those into MyOpenMath, but just if you want to write them down so that you can start on them right away, we will be doing numbers 6, 7, 8, 9, 10. So 6 through 10, number 13, number 15, and number 18, and number 21. And I will put those into my OpenMath when we're done here. Okay, any questions at all? We're just about done with our time. Anybody have any questions to ask? Okay. Well, enjoy your week and your weekend. And we will see you next week.